Hello everyone, welcome back to our video lecture series on AutoCAD. In the last session, we had discussed different types of 3D models or 3D drawings what you can prepare in AutoCAD, and also we did discuss an important concept, that is UCS. While preparing 2D drawing, the UCS was not of much relevance because we are always drawing in one plane or we are drawing in XY plane. But if you are thinking about 3D drawing, we have one more dimension coming up and we can orient our plane in different ways. We have seen some basics of UCS in the last session, and in fact in the last session itself I told I'll be revising the UCS concept in this session too. So I'll start with the discussion on UCS because UCS is very important when you think about 3D drawing. If you're not familiar with different options related to UCS, or if you're not familiar about the UCS concept, then it will be extremely difficult for you to prepare a proper 3D drawing. But AutoCAD has got a lot of provisions for that one. Only thing is you should be clear on certain important aspects as far as UCS is concerned. I'll not be discussing all the options. In fact, I'll be mentioning a couple of important aspects. So later, like once you are familiarized with these options, like you can go ahead and try various other options related to UCS. Okay, so for making simple drawing or normal type of drawing, 2 or 3 types of UCS will be much more than enough. But when it becomes some complicated drawing, like if you want to draw some springs or some elements which will be passing, which will be oriented in different planes, then it will like to have different other options also. Okay, so we'll go back to AutoCAD environment and we'll see. Okay, so I have something here in this drawing, and we have already seen like different planes in the or different UCS. So now if you see this figure, you can see the XY plane is oriented to the lower portion. So or XY plane is oriented to this. In fact, there are a lot of polylines. That is why the selection option is coming. So now my plane is like this, right? Okay, so it is parallel to the ground. In fact, I can say it is parallel to the ground. So whatever figure I will be drawing will be in that particular plane. So the concept is very clear. It's simple. Like if you think the plane as a sheet of paper, right? The plane, the drawing plane in AutoCAD is this XY plane, and this XY plane you can consider as your sheet of paper. So you can draw only on your sheet of paper. So if you want to draw something on a different surface, then basically you will have to reorient your paper, or you reorient your XY plane to the plane which you want to draw, right? So we have already seen in the last class the system variable UCS ortho. So UCS ortho is a system variable which decides how, or which decides how the UCS should work when we are changing to a standard view, right? So if you see here, the view is custom view. Now I'm just trying this to top view. I'm just moving this to top view. See, when I move to top view, now as our UCS is the world UCS or the initial UCS, so you can see that XY plane like this here. And now I will just move this to front plane, right? See, when I move to front plane, you can see that my UCS is reoriented to match this front, and here also you can see it is front is coming here, right? That means the UCS is changed to this front UCS, or we have shifted our paper. Like, no, initially our paper was like horizontal. Now we have shifted that to vertical, right? That is a front plane. So like this, you can reorient if you are okay. I'll just go to the home of these things and we'll have this parallel view so that it will be clearly visible, right? I'll just tilt a little bit. Fine. So, so if this is happening because I have made my UCS ortho value as 1, right? UCS ortho. Okay. So the current value is 1. That is why it is changing. See what happens if I put it as 0. See, I change this to 0. Now I am again going back to my top view. See, even if I am going back to my top view, you can see that my XY is not the world UCS now, or the initial one. It remains in the front. You can see here, it remains the front. Right. I will move back to okay, top view. Again, I will show the front view. See, the UCS is here in the front view. So if you make this UCS ortho value as 0, the UCS will not be changing. Like now, when you change to a standard view, the UCS will not be changing. But if you keep the value of UCS ortho as 1, whenever we move to a standard view, automatically the UCS also will be changed in such a manner that we can draw in that particular plane, right? So that is about UCS ortho system variable, which we have seen in the last class, but I just want to make sure that the concept is clear to you. Okay. Now, if you think, if you see here, we have different options here, like out of which, I mean, what I am shown in the last class was this 3-point UCS, and I will be mainly using this 3-point UCS in most of the cases, apart from this standard or the UCS related to the standard views. So even in the last class I mentioned that will be sufficient in most of the cases, but in certain cases we may require additional things, and for that we have various other options here, like we have like UCS aligned to a face of an object. Then you can align an UCS to an object itself, and you can align a UCS to the current view. Like if you take a particular view and if you want to orient your UCS to that view, that can be done. So these options you can try later once you are familiar with all these UCS options. And another important concept or another important aspect related to UCS is just make it more clear. Fine. Okay. I'll do a zoom R. Okay. Now you can see I have an object here in my. Okay, I'll go back to world UCS. Okay, UCS. Then I can have W for world UCS. World UCS means the one which we have started our drawing. Like the world UCS remains the same. Now I have a pyramid here. I'll show how I have drawn this pyramid later. Now I have a pyramid here, and I want to draw something on this face of this pyramid, right? Then I should orient my paper in such a manner that it is parallel to the face of the pyramid, or it is on that particular face. Of course, you can use this option here, that is face option of UCS to create a UCS which is on this face, or which matches this face. Okay, so in such a manner that our plane matches this particular face. Okay, but in AutoCAD we have certain provision that suppose if you start some drawing, if you want to draw some drawing on a face, then AutoCAD automatically detect that face and aligns a UCS there, right? Now just see whether that is happening or not. See, I'm just trying to draw a circle. And when I come here, see, this face is not highlighted. That means it is not detecting this particular face, right? And even if I start drawing it from here, you can see that the circle is coming in the plane which we have mentioned earlier, that is in the world plane. You can see that that circle is horizontal, right? It is drawn on a horizontal plane because that is the XY plane what we are having here, right? You can see this XY plane here, see. So it is in this plane, right? But what I want is I wanted this actually on this face. So I would have reoriented my UCS. But there is another system variable which helps you in detecting a face and making that as your current UCS without redefining your UCS. Okay. For that one, there is something called UCS select, right? It's not UCS. Yeah, sorry, it is not UCS select, it is UCS detect. Selection is something different, select mode is different, like whether UCS is selected or not. You have something called UCS detect, like it is actually detecting a face, so it is UCS detect. So if you see that UCS detect, the current value is 0. So now I'm going to change it as 1, right? It can take two values, either 0 or 1. So now I change the UCS detect value to 1, and now when I want to draw the circle and when I go to the face, you can see that that face is selected, right? Or that face is detected and a plane is oriented there so that I can draw in that plane. Now you can see the circle which I have drawn is on the face of the pyramid. Hope it is clear, right? Again, I will change the value for UCS detect and show it again. UCSD, yeah, UCS detect. The value I'm again changing to 0. Now I'll take this thing. So you see, whenever I'm coming here, like it is not detecting the face and it is not orienting the UCS to that one. Again, I'll have the same center, like, and draw the circle. You can see the difference. See, I used the same technique, or the same point was the center, but it acted in two different ways because the UCS detect value has been changed, right? The UCS detect value initially was actually it takes two values, that is 0 and 1. Initially it was 1, then later we changed to 0. So I'll just show it again. UCS detect. See, the current value is 0. 0 means it is not going to detect, like it is false. It is not going to detect. 1 means it will detect and will draw. Now we'll make to 1, and again I'll start circle comment and see. When my mouse reaches a particular face, that face is selected. Even if you want to draw on this face, you can use this one. See, you don't have to reorient your XY plane, or you don't have to reorient your paper, or we can say that UCS is not required to be reoriented. So if you want to draw on a particular face, AutoCAD automatically will be detecting that face and you can draw that one. So this is another important aspect as far as UCS is concerned, and this UCS is very important. Like, I mean, not only for drawing, even in editing. When you are modifying certain things, like if you are using trim command, then all those things should be in the same plane. Like if it is in a different plane, then we will have to change certain options. Then only it will be trimmed properly. So this plane, although like in certain CAD software, we'll be using the term plane, like SolidWorks or Solid Edge. Like instead of this UCS, the term plane is what we normally use. But in AutoCAD, like this can be, it is basically known as this UCS, that is user coordinate system, and you can have you can create different UCS, and even you can name the UCS, you can save that so that you can call back again and draw something on that one. So if you want to make a 3D drawing which will have too many components and other things, then basically you'll have to think about creating different UCSs and saving it by giving some names and calling it later, and again drawing something on those planes. So this is the basic concept about UCS. So this being one of the important aspect as far as 3D drawing, that's why I'm spending much time on discussing this UCS. Okay, so being covered the basics of UCS in detail. I mean, although like I haven't mentioned the other details or other options of UCS, which I think you can understand in due course of time. Like I'll be just leaving the discussion on UCS, and I'll be moving on how you can create 3D models. And I already discussed that. I mean, we will be dealing only about solid models. Like I'm not talking about wireframe or mesh or surface models. And for all those things, we have tabs here. Mesh is here, surface is here. And if you know how to create solid, then basically by seeing the various comments or various options, you will be able to create other types of 3D models also. Okay, or other types of 3D drawings also. I'll just take a pause, a small break, and I will come back to discuss on the basics of creating 3D drawings. Okay, so yeah, let us see how we can create a solid model. So I'll remove all these drawings. Let this be here so that we are sure about the plane in which we are drawing. Okay. Now, see, to draw 3D model, to create the 3D models, and we have already moved to this 3D modeling workspace. You can see here from, earlier when we were preparing 2D drawings, we are using this drafting and annotation workspace. Now we have moved to this 3D modeling workspace, and in 3D modeling, in home, you have certain buttons here, and in solid, like if you go to solid, they will have various options related to solid here. So, but right now, I'll be using the home tab only, like now, after and if you want more options, like you can go to this solid tab where we'll have different options, and most of these options, the basic options what we want will be available here in home tab. So I'll be discussing or showing the details here, and then maybe whenever we require, we can move to the solid tab. So one way of creating solid model is by using the standard objects or the standard types of 3D objects. See, these standard objects we can draw, like this is box, like if you want to make a block, then you can use this box option, right? Then we have cylinder here, you have cone here, sphere here, pyramid here, wedge here, torus. We have seen what donut is in 2D drawing. So like giving the third dimension to donut, we can create a torus. So for these items, you can create it very easily just by giving the dimension. I'll show you a couple of items. See, for creating box, like we can start the box comment. When I click that one, you will be starting the box comment. Then for box, actually we require a rectangle initially, so it is asking for the first corner, or alternatively you can give the center. I think by this time you will be able to understand, like how we can select different options, or how we can communicate to AutoCAD by looking into the cursor or by looking into the command line. Okay, so here I am giving this as my first point, and then I'm giving this as my second point. You can see that our UCS is world UCS, that our XY plane. So the first phase, it is drawn on that XY plane, right? So I'm giving the second corner. Now it wants the height, right? So once the height is given, all these three details are given, you will be getting a like a box here, right? A solid box. This is a solid object, right? This is how we can create standard objects. So we have seen how to create box. Similarly, cylinder. See, for cylinder, we need a circle initially, so it will be asking for the center, and we have the other options also. See, 2p, sorry, 2p, 3p, ttr, and if you want even elliptical, you can use that option also. Okay, so here I'm using the default option, so I can use maybe 100 as the radius, then height say another 200, 300, 300. So I got a cylinder like this. Okay, so cylinder we have, then cone we have, sphere we have, pyramid we have. So all these things are possible, right? Or other things you can try out. Now what if I want it oriented in a different manner, right? Suppose the cylinder which I have drawn right now is having its base in the XY plane, which is parallel to the ground right now, or the world uses. Now what if I want the base of the cylinder here? Then I can reorient my UCS. I'll just use this 3-point UCS. This is my positive X direction, and this is my positive Y direction. Now you can see that the XY plane is oriented like this. I will make the grid off, otherwise it will get confused. Okay, now it is better. It looks better. Now you can see that our plane, or our XY plane is like this. So whatever I will be drawing, it will be coming on this plane. So again, I am clicking the, I'm going to draw a circle, like now a cylinder. So now when I pick the point, you can see the circle is coming on this plane, right? And when height is given, right? So we have reoriented. Like now we can draw 3D object like this in different planes. So this is how you can draw the standard 3D objects, right? So for drawing standard 3D objects, you can select the command from here, and according to that, you can I mean, according to the type of model which you are giving, you can give the dimensions, and the model will be constructed. Only thing what you need to take care is the UCS in which you are going to create the base. Okay, when static. So the plane should be selected properly so that our base will be on that particular plane, right? Then we will be giving a Z direction. So this is how we can create standard elements, or we can call primitives, like the basic 3D objects, right? Now we'll see if we don't want to use the standard type of elements, and if you want some specific type of solid models which is not matching the standard element, then we can have a couple of other comments also. Basically, there are 3 comments here. I mean, there are 4. I mean, out of which the 3 is most important. Like, you know, the loft will consider later. So the other 3, that is extrude, revolve, and sweep. I'll just type here. Right now we have this here. 30. Okay, that is extrude. Oh, I think, sorry, I'll be covering that area. Extrude, revolve, and sweep. So by using these 3 comments, by using these 3 comments, I will just increase the, yeah. By using these 3 comments, you can create 3D objects from 2D drawing, right? You need to draw some 2D drawing and use this comment to develop 3D drawing or 3D model from 2D. Also, we have that loft, in fact, but majority of the items we can draw by using these 3. When your loft is not there, we'll be able to create that object. We'll see loft also, that maybe later. Okay, so I just minimize that one. So first we will see what this extrude is. So for that, I mean, I'm again going back to my world UCS or the plane which is parallel to ground. Now the plane is this yellow, or like now this highlighted is our plane. So I want to go back to this plane. So I will change UCS to world UCS, right? So my UCS is now this, or my plane is this lower rectangle what we are seeing here. Fine. Okay. Okay, now we have created cylinder by using the standard command. So here I'll show how I can create a cylinder by using the extrude command. So first of all, I'll be drawing a circle here. See, I'm just drawing a circle here. Now extrude means actually I can pull this in Z direction. It is something like pulling that in Z direction and creating a solid object. So I'll have this extrude command here. Then it will be asking me to select the object, right? I'm going to select the object and press enter. Now you can see that that object is being extruded. So whatever height you want, maybe say 300. So I got a cylinder like this, right? But you may be having a doubt like, now why should I use extrude? Can't I use the standard cylinder command too? Yes, of course. I mean, like, no, for creating cylinder that is possible. But what if you want something else? Like, I'll just show you. I'll use a polyline. Just to which is my plane. I'll just zoom previous. Just delete that. Yes, is in the XY plane. I'll orient it properly, right? I'm just starting the polyline command. Just draw something, some irregular shape. Yeah. Right now I have a figure like this, and I want an object like this. So now we'll have this extrude command. Select this object. Select this. See. Now we have an object which has been extruded. So extrusion is very simple. You need to create a closed, even if it is not closed, I will see if you are extruding line, actually only the outer these things will be coming. So I will just draw a line here. See, line, and I try extruding that one. See, only a sheet like sheet will be created. But if you have closed figure like rectangle, circle, or polyline, then we will have a solid in that one. Or else, if you are creating it with a line or other similar type of entities, then you have to make sure that there is a closed figure, and you can create a region out of that one. I think we have seen the region in the initial classes. If not, you can pause. We will see, or you can just try in the drawing comments. Like, I mean, there is something called region. So the region can be created and region can be extruded, so that we will get a solid model. So this is about extrusion. So in the case of extrusion, actually we are giving a Z direction, or the third dimension is given. Okay, I don't want it like that. Let it be like this. Okay. Also, the extrude command, you will you can extrude in another way also. So UCS, if I want to change the UCS again, I'll show it in the other plane. So I'll change the UCS to the this inclined plane, or this angle plane here. So now the UCS is here. So I'm drawing something on this. You can have arc there, that one, arc. Then I'll again go back to line, then close. Say I have an object like this, then I'll use this extrude command, select this, and see the extrusion is happening in this direction or in this direction. So by changing the UCS, you can change your plane and you can create your base there, and which can be extruded. So this is about extrusion. Now I'll keep my plane here itself so that it will be easy for you. Now the next command is revolve. Revolve is revolving a 2D object or revolving a region or something, I mean, along an axis, so that it will be rotated 360 degree, or it will be revolved 360 degree, or at a particular angle, so that a solid object will be obtained. See, we have created a cylinder by standard command, and also we have created cylinder by extrusion. Now we are going to see how I can create a cylinder by revolving. So here I'm again using this polyline command, right? Or I'll be drawing a rectangle. The rectangle will be easy. So I'm just drawing a rectangle here, right? See, I have a rectangle in this plane. Now what I want is, I want to revolve this rectangle with respect to this line, with respect to this edge. What will I get? See, this rectangle, you can think it as a sheet of paper. This sheet of paper is revolved with respect to one of its edges. So ultimately we will be getting a cylinder, right? I'll show that. Just using the revolve command. Revolve command, first it will be asking me to select the object which is to be revolved. So this is the object which is to be revolved. Then it will ask the axis, right? For axis I can specify 2 points, so that will be taken. So this end point and this end point, that is my axis. Now you can see that it is revolving, right? And if you want complete 360, that will be the default option, or else you can have that start angle, end angle, and all those options. But right now I'll be using the default option, complete 360. So I'll be pressing enter. Now you can see that we got a cylinder, right? Now we are seeing drawing the cylinder in 3 different ways, right? You can use the standard command, or you can use extrude, or you can use revolve, right? Even by using the next option also it is possible. So this is about revolving. So you can revolve any object. So we'll try one more thing, right? This time I'll make it a little bigger. Fine. Again, I'll just change it to some other. I think just to have some change, I'm using just drawing some polyline, right? Arc, line, okay. So I have a figure like this. Now I'm going to revolve this with respect to this line, right? And I'm using the revolve command, selecting the object to be revolved, then axis first point, axis second point, you can see. So I'll be using all 360. So press enter. Yeah, see, we got some model like very easily. So this is about revolve, right? Now we'll see the next one, that is sweep, right? For sweep, actually we need 2 drawings, like 2D drawings. One is a profile which is to be swept, and a path through which it has to be swept, right? So okay, you can do, I will just move the UCS to world UCS now, UCS world, so that now my UCS is this ground UCS here. So now I'm creating a circle here, maybe at some point we'll have a circle. 50. I'll give diameter as 40. So I have a circle here. Now I am moving my UCS to the previous UCS. So UCS, and we have an option here, previous. See, if I use previous, then it will be moving to the last UCS what we have created, or the previous UCS what we have used. So now I have the previous UCS. Now here I'm going to draw a polyline, an arc in fact, an arc with this point and this point. Okay, fine. Now I have an arc like this, and I have a circle this. So I'll be using this circle as my profile and this arc, this polyline as my path. So what if I take this circle and pull it along this path, I'll be getting a solid. So this is what we are going to do when we are sweeping a particular path, right? Rather than explaining, I can just show that. We'll use the sweep command. First it will be asking the objective sweep, or I can say that it is the profile what I want to sweep. Okay, once I complete the selection of the object, I can press enter. Then it will ask me the path, right? So this is the path. Now you can see that the circle is swept through the path and we got an object. So this is about sweeping. So we have seen three basic or important commands, that is extrude, revolve and sweep, right? Loft I'm leaving to you. Once you understand this concept, you can see how loft is working. Like in the case of loft, like we can give some angle or something like that. I mean, like which will be, I think you can try it out, and if you feel any difficulty, you can discuss here so that I can show or demonstrate that one. So with these three things, I am concluding this video. So we have seen the basic three like commands by which we can create 3D models from irregular drawings or irregular shape. One is extrude, the next one is sweep, and the other one is revolve, right? And we have another important option which is called press pull to create some object. That we will see in the next session. And another important concept here is, like, we have only talked about creating objects here, right? We are adding something and creating the solid. So what if I want to create a hole? How can you create that? So those things is another aspect what we let. So for that we need to understand how we can edit solids. Like now we have a couple of commands for editing solids, which we'll be discussing after, maybe in the next session. Like we'll see in the next session this press pull and this solid editing we'll be discussing in the next session. And with that, most of the basic details for creating 3D will be completed. Then we can take some samples and draw, so that you will be familiarized with all these 3D aspects. Okay then, so that's all for this session. Thank you for watching, and if you have any doubt, as usual, you can always discuss with me, and some of you are already interacting with me, so please interact with us. I mean, you know, the conditions are not good as far as the general thing is concerned. So stay home, stay safe, and please do find time to please do utilize your time efficiently, so that you can learn these things. Okay then, thank you, bye.